is this?
I call that
You're using Rose Bowl, right?
But nothing that's like, oh, I want to do this.
I don't know. Do they have any kind of like a bill? I don't know anything like they bill or anything.
What about what you mentioned? Like, matching up with the
Can you be a mentor? Can you be a big sister?
But I go to
Well, I mean, like if like
yeah, like we have like
so it's like even just for like a couple of weeks.
Yeah.
I was in that.
I'm
Like
so
go organize like a closet or something.
They just say straight.
So was it your first safe place? Well, we're a third of the way through.
Don't do that.
I kind of am obsessed with this is not a 12-week semester. Sure, yeah, like it was last one. I feel like it's the
Yeah, now I have these days and I'll run to the end of.
All right, so today we are looking at June the 6th. So we're working on discrete probability distributions. So this is one part of chapter 5, I'm pretty sure. So we're dealing with questions about probabilities that are given to us for specific lists of events. But more than that, for specific numbers. So we have a number that's associated with a probability, and we're trying to figure out what we can know based on that kind of a situation. So I did have a few people who contacted me about the homework. Specifically, it's helpful for me if you run into a problem with the homework, that if you can let me know right away, like through a text or a cell phone call, so that I can take a look at it and see if there's something that makes for a quick fix. I can fix things after the fact, okay? Once you submit a homework assignment, I can change everything to 100%. I have the ability to do that. So, if you just say, well, I just want you to give me 100% all the time, well, I could, but then that wouldn't really help you, would it? Because then when it comes to test, you wouldn't know what's going on. So what needs to happen then is that we need to figure out if something's wrong. And specifically, if you find that you're putting in an answer and it's just a little bit different then what the correct answer is, the software is supposed to know that. The software is supposed to take that into account. So that if there's a little bit wrong on your answer, it says, oh, that's pretty close enough, good enough, fine. It's supposed to do that. If it's not doing it, it's wrong. And so then I need to contact the textbook publisher and say to them, hey, fix this, will you? So all that stuff is involved here. Of course, the main and important thing is, do you actually know what's going on? If you know what's going on, that's the big deal. If you don't know what's going on, that's more of an important fix that needs to happen, right? So I really need to know that. Unfortunately, most people don't do that. If they don't know what's going on, they just stop. And then unfortunately, they're not able to continue because they just stop. So the big deal is, do you know what's going on? And if you don't, will you ask me or somebody else to help you and figure out what's going on? And then we're okay. Then we're good. So then, if we look at the specifics of this homework assignment, all right, if we're looking here at question number 1, it says, here are the number of accidents that people have per day on a certain freeway. And so we have the number of accidents, and then we have their probabilities. And it asks you to find the mean, the variance, and the standard deviation. So then for these things, when we say, how do you find this? Mean, which is this symbol, mu, you take each data value, the data values are the number of accidents, and multiply it by its probability. So this is one number, the data value. This is another number, the probability. This X right here is a label telling you which one of the probabilities it is. So if I say, what's the probability of 3, it would be 0.1. Okay, so this, the letter that comes after the P, or the thing that's in the parentheses, is telling you which one it is. So then you have 0, 1, 2, 3, 4, and each one of those is multiplied by its probability. Add all those numbers up, and you get the mean, which is telling you the average number of accidents then, based on this situation. All right, does anybody have a question about finding the mean and how that's supposed to happen? Okay, so then standard deviation looks like this. Now, I will give you these formulas. You don't have to memorize them. But if you're going to do your homework, you have to know these formulas. You have to know which formula you're using in order to make this happen. This is the standard deviation then. We use the symbol small sigma. So then what we would be using is each data value is squared, then multiplied by its probability. After we make that list of things, then we add all those up. We subtract the square of this number, the mean number, take the square root of that. That gives us the standard deviation. Now the textbook, for whatever reason, they love to talk about the variance, which is just taking the square of the standard deviation. So if you find the standard deviation, then you square it with the variance, right? And it says that they want you to round your answer to 1 decimal place as needed. What that means is, while you're doing the problem, you should probably have 2 or 3 decimal places. And then when you get down to the end, you round it off to 1 decimal place, and it's good. Right? That's how it's supposed to work. All right, does anybody have any question about this process so far? Okay, so I want you to do this problem. I want you to find the mean and the standard deviation and the variance. for this right here. And I'm going to write it up here larger so you can see the numbers. So I've got 0, 1, 2, 3, 4. I've got X here. I've got my probabilities, 0.3, 0.1, 0.1, 0.1, 0.4. All right, so see if your neighbor is doing things correctly here. Check with them, see if what they have is the same as what you have, and if you're going through the same procedure. What that means is I want you to stop working on the problem right now. I want you to look at what someone else is doing and see if it's the same as yours.
That's the whole.
Is that the right answer? I mean, as far as like. Yeah, I was looking at that wrong.
Oh, yeah, you used to that,
I have a problem.
I know that thing that I ran into you about last night. You were right, it just didn't go far enough. So I did like 6 for the standard deviation. I got 1.72. We did.
I'm not doing my homework. How did you rate it?
All right, Taylor, what do you got for the mean? It is 2.2. Okay, so what we do is we multiply each one of these, x times the probability. This is 0, 0.1, 0.2, 0.3, and 1.6. You add those together, we get 2.2. Can somebody explain to me why that number is reasonable? Why is it reasonable that we would have a mean of 2.2?
What's your question?
My question is, why is that number reasonable? Why is it reasonable that we would have 2.2 as a mean? It's between 0 and 4 because that's what we're measuring. We're measuring the thing that goes from 0 to 4, which is the number of accidents. And so since it's between 0 and 4, that makes sense that it would be 2.2, about halfway in the middle. That makes sense, right? So now we need to know what that number is for the standard deviation. Janan, can you tell me what you got for standard deviation? Actually, no, that's the variance. I wanted to know the standard deviation. Okay. So if you do square root of 2.96, 1.72, and we could round that off to be 1.7. That would be a reasonable number, okay? So this would come out to be 1.72, and this is 2.96, more or less.
So if you rounded that, would that be 3? Is that
Yes.
what they wanted?
Yes. If I round this off to the nearest 10th, okay? If I round this off to the nearest 10th, it's actually 3.0, right? And that shows that the 0 is part of it.
So I have to write 3.0.
If you do it for the textbook homework, they should take that as an. They should take 3 or 3.0. Okay? Now, how do we get that answer? We would square x and multiply it by its probability. So this is also 0, 0.1, 0.4, 0.9, 0.4. Okay? So what needs to happen here is that you need to understand not just how those numbers get to be what they are, but how they would go into the formula in order to get the answer for the standard deviation and for the variance. So this is x squared multiplied by p. This tells us to add all those numbers together, subtract 2.2 squared, and then take the square root in order to get that standard deviation question.
In all these problems, will you always give us the x data value and then the p times x? Is that how it'll always start?
Yes. Okay. when we look at this and we say, okay, you could have started with frequency and made the probability based on the frequency. That's another possibility, but this would be more reasonable. Okay? All right, so Evie, did you get this answer? 1.72 for the standard deviation, 2.96 for the variance? Did you get 2.2 for the mean?
Yes.
Okay. Did you get these numbers in this last column? Okay. So if you have these numbers, when you squared x and you got these numbers here, if you add these up, hopefully you would get 7.8. Did you get that number? 7.8. Okay. So then this would be 7.8 minus 2.2 squared, and then square root of it. Right? Emily Yang, did you get this number? For the standard deviation, 1.72?
Yeah.
Okay. All right. Any other questions out here about this process? Okay, so then the next thing, that's exactly what we're doing right now. Okay, yes, the next one, the next one. Okay, so the next one is like this. Here, this contractor is going to do a certain number of jobs. And when we look at this, we say, well, how many jobs could this contractor do? Somewhere between 1 and 4, but they're not all the same probability. It's more likely that they would have 3 jobs and not have 4 jobs. So then, when we look at this in terms of the profit, and it's not necessarily abundantly clear here, but hopefully it makes some sense to you. $2,750 profit is the number of profit on each job. So each of these jobs would be a profit of $2,750. So if each job has a profit of $2,750, then if we want to know what is the expected profit, we would need to know how many jobs is this person going to do? Well, then, when we're looking at how many jobs the person does, we're going to be dealing with the average. So we're going to use this same process that we just did to find the average. We're going to take the number of jobs times the probability, add those numbers up. That will tell me how many jobs. And then I'll take that number, multiply that by 2750, and that will tell me how much profit I'm making. That's one way to do the problem. Another way would be to take each one of these numbers, 1, 2, 3, 4, multiply by the 2750, and then do the process. That would also work. Either way is fine.
How did you know what to do?
Okay, when it says, find the contractor's expected profit each month, okay? Then I ask the question, how do I know what the profit is? I look at the top of the problem. It says 2,750 profit on jobs where he can make this. So each job gives you that much money. So this, I have to be able to connect to say that the profit is equal to 2750 multiplied by the number of judges. Okay? I make that connection based on what it said in the first statement right there. Now, how do I know I'm going to do this? Take the number of jobs multiplied by the probabilities? Well, that's what we're doing in this section. We're doing this thing. So then it would make sense that I'd be using this formula because that's the formula that we're using in this section. Now, another way that I would know what to do would be if I hit this right here, show examples. And then it would tell me. That's what I'm supposed to do in this situation.
So when you were
Okay.
saying the other way to do it, were you saying the 2750 times the number of jobs, which would be 4, right?
I'm sorry, hang on a sec. It would be 2750 times each one of those numbers. 2750 times 1, 2750 times 2, times 3, times 4. And that would be my profit for each of those situations. And then I would multiply each one times its
By
probability.
the probability.
Yes. That would also
After
work.
you times it by 1, times 2, times 3, times 4, then you would times it by 0.2, 0.3, 0.4.
Each one of them, yes. Yes. We could do it that way. It seems shorter to do it the other way. Right? Okay, Natasha, did I answer your question?
Feel really lost.
Okay. All right.
Because I don't know where to come up with the equation, the total, X, like in my head when I look at that problem. I use guided solution to get through the homework.
Okay, first
and
of
it
all,
shows
I
it
got to
a
ask you
different way,
something, all right?
it seems like.
First of all, I got to ask you this, all right? If we're doing this particular section of these kinds of problems in the textbook, how do I know what formulas I'm going to be using? I'd be looking at this section. I'm not going to bring a
Maybe on
formula
textbook,
from
but
anywhere
I'm
else.
talking about if I'm on a test and I don't have that textbook.
Okay,
for
I'm gonna,
reference.
I have to stop you again, all right? Because I could go on for another 15 minutes to explore this, but I'm hopefully gonna save you the problem right here. You're gonna have a practice test. It's gonna tell you what's gonna be on the test. You don't have to worry about how you're gonna figure out what kind of problem it is. Because you're going to have one problem that looks like this. And that's the only kind of problem that's gonna look like that. And you're gonna know what kind of thing it is because it's gonna say discrete probability distribution, here's the formulas. And you're only gonna have one problem that's a discrete probability distribution. There's only gonna be one problem that looks like this, that has a list of numbers and a list of probabilities. And you only have one possible equation you can use for that, this one. And the standard deviation one, which we just did. Okay? So I understand that you're thinking about how am I going to know when the actual time comes that I'm going to know that this is the kind of thing I'm going to use for that problem, right? But what I'm trying to say to you is that it'll be clear once we get there. It might not be clear right now, but it will be clear when we get there. I'm going to ask you these questions in order of how we go through them. The first question is going to look like this. You're going to know that that's what the problem is. All right? Does that help you?
Yeah.
All right. Okay. Natasha, doing this particular problem, did you work on it while we were talking?
I just did the X times, yeah, that's all I did. And
Okay.
then the profit jobs, I multiplied that on the 2750 times the number of jobs, and that's all I have. No, I don't know what to do.
Okay. So, oops, I got to answer the end. What did you get for an answer?
For what?
When you multiplied 2750 times the average.
I didn't do that. I said
Oh.
I did on my next step after I figured out the profit of each job.
Oh, okay, so you multiply the 2750 times each one of these.
And that's all the correct.
Okay, so then if you take that number and multiply it by each one of these probabilities,
So
okay?
I multiplied job 1, which would be 2750 times 1,
2.
times the probability.
Right.
times probability, that's correct?
Yes. And then the next one, 2 jobs, which would be 5,500.
Right. And what answer is that giving me when after I give it, what is that?
Okay, you're not done yet, okay? After you, okay, I want you to not push any buttons right now. All right, I want you to listen to what I'm gonna say, all right? After you take each one of those numbers and multiply all of them times their probabilities, you're gonna get 4 answers. You're gonna add those answers together. That's what you want to put in this line. All right? Now, I understand that you're going to do that right now, okay? But when you say, what am I getting when I do each one of these? You're not getting something when you do them separately. When you add them together, that's when you're getting this answer.
I'm getting an expected profit per month per number of jobs, and then I add them all together to know the total amount in the month. I'm asking for profit a job when I do the 2,750 times the probability of 0.2. That answer, what does that answer mean?
Okay, what that answer means is how much profit you are getting from doing one job,
in a
which
month?
only happens 20% of the time. Okay? Not all of your jobs are just one.
Right.
Some of them are 2, some are 3, some are 4.
I just have to know like each step I'm doing and what it means.
Okay, unfortunately, it's not going to work that way. Okay? If you try to understand what every piece of it means, you won't be able to make progress. What you have to do is just do the thing without knowing what those numbers actually mean. Later, it'll come clear. You've got to be able to just do this thing right here without understanding what it is. You have to just do it. And then you're going to understand what it means later. And I'm saying this because it's true for everybody. Everybody struggles with this. I can't explain to you every step of every problem. But I can say that if you know how to do the equations and get the answer, it will come clear to you later. But it won't happen right away.
Can you?
Right?
6 weeks.
6 weeks.
Yeah, 6 weeks, usually, maybe 4 weeks. Depends on the person. Okay, so.
I just feel like the standard deviation, like when I was doing the homework last night, is just so different from the standard deviation I feel I grasped last.
It is.
It's just like, wait, this isn't standard D, this is like a standard deviation 2.0 or something. It's
It is.
different.
It is.
I don't like that.
All right, sorry.
I was getting the other one.
All right, that's exactly what's going to happen all term long.
Great.
Every class period, you're going to run into something and you're not going to have a clue what we're talking about. But the stuff from 3 weeks ago is going to be, oh yeah, that's pretty simple now. Yeah.
So it was definitely my.
1,600 was the answer.
Okay, so if I go 1, 2, 3, 4, and I've got 2, 3, 4, and 1, 0.2, 0.3, 0.4, 0.1, 2.4, this times 2750, 6,600, yeah. Okay. So that's that one. All right. So I want to try to help you here. Try to help you a little bit. Try not to overthink. Do the thing. Do the thing. You don't have to understand the thing. Do the thing. No.
Do the damn thing.
There you go. All right. Fortunately, I've never watched Bachelorettes nor Bachelors. So yeah, fortunately, I'm never.
So much drama.
Nothing like
It's a reality TV show or whatever it is.
Okay. So now we're going to talk about this question number 3. We talked about this a little bit earlier. Now we're going to talk about it some more. And what we're talking about here is two things that are going to happen. There are two options when you buy life insurance. You live or you die. Those are the two options, all right? I'm a firm believer, I used to actually sell life insurance. I'm a firm believer in life insurance. I think it's important, I think it's good. It's crazy and it's weird, but yeah, it's a good thing. All right? There are bad people out there who sell you bad products, but there are also good people. Like used cars. Okay, so now we have a life insurance policy. Now, we're going to talk about the probability first. So I'm going to put the probability out here, and then we're going to put the X over there, okay? So we say, what's the probability that you will survive? In this case, 999,055. That's the probability that you will live. Okay? So how do we find the probability that you die? Dave, did you say something?
Yeah, it wouldn't be the remainder of 1.
It would. So we're going to take 1 minus 0.999055, and we get 0.000945. Fortunately, for this person, they're probably going to live. That's what we want. Okay? We can talk about living in other countries, but we're not gonna. We're just gonna say you're gonna live. Okay, good. So then, the question is, what happens if you die? Okay? If you die, you will get $100,000, but you had to pay $540. Okay, so if we take $100,000 and we subtract 540, you get 99,460. Oops, if you die. What happens if you live? You paid $540. So that's actually a negative number, $540. Okay. Now, there is another option you could do for setting this up. You could have it over here, that you live or you die. And you could just talk about the $100,000. Okay? If you die, which is this, you get $100,000. You live, you get nothing. Okay? What this is talking about is just how much money you receive from the insurance company. The other one includes the payment of the premium. With this method here, you would figure this out, but then you would have to subtract the premium because you had to pay the premium. Okay? But if you do it over that way, you've already taken the premium into account. Either way is okay, as long as you get the right answer, which is what we're after, the right answer. Okay? Now, what formula are we going to use? The same formula we talked about earlier. X multiplied by the probability. That's what we're going to do. So, do it either way here. 540 negative number times 0.995 is this number. Negative 530. What's the other one? 99,460 times 945. 39 or 93. Add those up. I'm pretty sure that's right. Oh. Well, I must have put it in. Let me try again.
Yeah, because I got the answer on the board and I didn't round anything.
All right, so I'm going to try 93.9857 or 9897 minus 93.9897 minus 539. 4897. Oh, 445. Yep. I'm not sure if you're putting in the negative sign. Okay, if you have the negative number in for the 540. Okay, if you have negative 539.4897 plus 93.9897, you should get negative 445.50.
I got the same answer, but not
I
negative.
didn't get negative either.
I did it the way the homework taught us.
Okay, if I do it this way, what I'm looking at is that this is what I receive from the insurance company. And this is what I pay to the insurance company.
Right.
So it's negative for me or positive for me. Okay? But the question is actually asking, what is it for the insurance company? So if I'm doing it for the insurance company, this is going to be positive 540. This is going to be negative.
Yes, that's how I had it set up.
Okay,
That's how
you
I
did it like
understand.
that, okay? This is for the insurance company. They get this if I live. They pay this out if I die.
Right.
Okay, so then these will switch around, so this will be a positive number.
Okay.
445.50.
But that's not what the question's asking. It's asking,
That is what the question is asking. The question is asking, what is this for the insurance company? 445.50. Correct.
This might be a stupid question, but
But-
does the negative, like, since we got a negative here, does it not necessarily matter because, like, either way, that would be how much they would be getting?
Yes, either way, it's how much they're getting, but you have to think about, if you ask the question, how much does the insurance company get? The answer is 445.50. This would be how much I paid the insurance company. This is how much the insurance company receives.
So like
So
when we,
either way,
okay, so when we answered on there, like the negative, like,
it goes away once you think about where's the money going. It's going to the insurance company.
a negative sign is what.
But if you say 540, how did they only get 445? You're out.
Okay, I got to back you up a little bit, all right? We're not talking about how much actual money they're getting from you. We're talking about the average amount they're getting for everybody. They're getting 540 from, right. That's why it changed. Exactly. Okay?
And then how do you know to make that positive if the answer was negative?
Okay. What we were just talking about was, if I look at this, this is how much money I paid out. The question is asking how much money does the insurance company
So
get?
that came.
So that's why it becomes possible. All right. So now we've done all three problems that are on the homework. Okay. All right. Any further questions about the homework? All right.
Can I redo it now?
Sure, absolutely. That's not a problem at all. You can redo it. I can fix that. Okay? So, we can make that happen. All right. So, again, the concept here of what this actually means. What it means is that it's not happening, like we just said, it's not happening for each person individually. It's on average for all the people put together. And so then, this is how we come up with ideas about what's the chances of somebody getting well from a particular medicine, okay? People are going to have, there's going to be a certain amount of success, right? You're going to say, we give people medicine, some of them are going to get better, all right? How many of them? You don't know. But you can get an idea of how many might get better based on the probabilities. And so, yeah, I mean, it's really a lot more complicated because you have a lot more things going on than just live or die. And these probabilities get a lot more complicated. But that's the idea of what we expect to happen for the average. Okay? All right. Now, what we're going to do next, and I want to kind of get back to how we were describing the situation. When we said yeah, the two different kinds of probability that we were talking about. If I have something like this, and I have like Packer fans and Chicago Bear fans, and if I say, do they like oranges or apples or other? And I'm putting numbers in here, 70, 30, 10, 10, 5, 14, 15 or something, okay? This thing right here, if I want to know my probability, I'm going to take the number in a specific set divided by the total. So this is one kind of probability that we're talking about. Getting the specific set and dividing it by the total. And we get it from our description of these categories. Okay? That's one kind of observed probability. But now we're going to be talking about a different kind of a situation, different thing, if you want to draw lines here, different situation. In this situation, we have to be given, we must have given to us a general probability. Somebody somewhere figured out what the chances are of something happening, just in general. And we have to be told what that is. And then based on that, we have given to us a general probability. From there, we're going to determine the number of events Okay, so we're given a general probability, and now we're asking the question, what can I expect to happen? What will I get if I already know a general probability ahead of time? So, for example, let's say that I've got a situation where, let's say, I'm given that 40% of students let's say, I don't know if I want to do that. Yeah, let's say 40% of students are on a sports team. So I'm told that in a particular school, 40% of the students are on a sports team. Okay? And then I'm going to look at let's say 6 students that are, let's see, why don't want to do that? Let's just say, yeah, 6 students that are taking art class, sure. And I'm going to ask the question, how many of the 6 do I expect to be on the sports team? Just by chance, okay? So I'm looking at a situation. I have a general probability in mind. I have to have that for these kinds of problems. And then based on that general probability, I ask a question, what is going to happen with this group of 6? How many students am I going to expect out of those 6? How many would I expect to be on the sports team? Now we already know how to do this if all of them or none of them, okay? So let's find out what's the probability for all of them to be on the sports team. How would I figure out the probability that all of them are on a sports team? It is 0.40 to the 6th power. 0.4 to the 6th power. All right, what's that number? Okay, let's go to 4 decimal places.
Isn't that still 4? Or do you mean like?
If I go 0.4 to the 6th power, and I want 4 decimal places, 0.0041, right?
So I thought that the zeros didn't count because there wasn't a number like in front of them. Like they were like non-important zeros.
If I had said I want 4 digits of accuracy,
Okay.
then that would be correct.
That makes
But I want 4 decimal places.
Okay.
All right. Okay, now, if just by chance you've decided not to do this kind of thing when I put it up on the board, I would recommend that you still try it, okay? Even if we do it and we get an answer, I want to make sure you know how your calculator works so that you're actually also getting this answer, okay? So what about the probability of none of them? Well, that would mean that's not 40%, but 60%, okay? So this would be 0.6. Or
0.047.
okay. Uh, 467 if we're going to go out to 4 decimal places. So, I walk into the art class. There's 6 students. And I say to them, hey, is anybody here on a sports team? And they say, no, nobody. Is that somewhat surprising? Why would you say that? It's under 5%, so I would be kind of surprised if nobody's on a sports team. What if I walk in and say, hey, art class students, how many of you are on a sport team? And they say, we all are. Yes, all 6 of us. Then what? I'm really surprised because that's a really low chance of happening. Okay? So now the next question that we need to answer is, what do I expect to happen? What are the probabilities between those? Not everybody, not nobody. What's in between? Okay? And then the question would be, well, how would I go about figuring that out? Well, if you think about a tree diagram, we would have to go through all the different possible ways of arranging students. Either the first one could be, or the second one and third one and fourth one could be, or the second and the fifth and the sixth one could be. So there's a lot of different things that could happen here. So instead of actually going through and figuring all that, we're going to have a mathematical formula that's going to make that happen. But we're going to wait until after the break to talk about that. Okay, so we're going to take a break right now. 3:55. We'll come back at 4:05. Let's do that.
Would be looking for something other like a.
No, it is going to be a probability.
This is going to be a problem.
It is. We'll talk about that.
that.
Oh, that other one? Oh, that's that other problem we did. That's another kind of problem. Okay. This kind of problem is where you have a list of things and you have a list of probabilities. Like 1, 2, 3.
And you're looking for the data value,
5.
or you could be looking for either one, I suppose.
Yeah, and here you're looking for the average, basically, the mean of the data. Yes. Yeah, that's a good idea. So I'll talk about this.
I was just trying to figure out like where.
Yeah, which one was it goes. Yeah, that's right. All right, so Eric had a good idea here that I want to talk about to kind of separate out the different kinds of problems, which you asked the question, what kind of problems are we having? So then this one, which we talked about, where you have a list of categories and the numbers of people in the categories, then you find probabilities by doing this, taking the number of people in the set divided by the total.
All the time.
No, over here then, we had what we were just talking about, which is that you have a list of numbers and you have a list of probabilities that go with those numbers. And then you're finding the mean of that data value, like how many jobs you get, how many eggs you eat, how many whatevers, right? So this is a different kind of a situation. This is where you have a list of probabilities that's given to you, and then you have a list of numbers that could happen with those probabilities. So how many records are they going to buy? How many tacos did you eat? How many people watched the Super Bowl or whatever it is? How many people in your family? All those things. That's a number that you're trying to find the average by using that formula that we had, the sum of x times the probability. Okay? So here you have numbers with a list of probabilities. Here you have a list of frequencies or a list of categories with numbers of people in them. And then you can make those into probabilities if you divide by the total. This is something else. Okay, this is the third thing. This is where we're given some general probability idea, like 40% of all the students are on sports teams. And then we're trying to figure out what to expect out of some set that we're given, like the 6. Out of those 6 students, how many of them will be on a sports team? Okay? So we figured out the probability that all of them, we also figured out the probability that none of them would be. And now we're going to try to figure out what's in between.
Can you repeat what the third one is again?
This third one here,
All that.
all this, okay? We have to be given a general probability that something's going to happen.
Right.
And then using that general probability, we're now looking at a smaller group and saying, from that smaller group, how many of them will be in that category, whatever it is.
You're
So
looking at a smaller group to make a smaller group?
we are going to be looking at a smaller group of the smaller group. Okay? And we're looking at what are the chances for the different possibilities. Okay? All right. So when we do that, as I mentioned, if we start to ask the question, how many outcomes are there? There's a lot of different things that could happen. You could have the first student is in the sports team and the last one, or the second student and the 5th student, or the 2nd, 4th, and 5th. You have all kinds of different things that could happen. Well, how can we make a list of those? We're not going to. Okay? There's a mathematical way to do that. So if we want to know, how can we find the number of ways for something like this to happen? There is a number that you're going to be able to find on your calculator that will tell you that, okay? And so what we're going to look at, I'm going to show you where the number comes from, and then we're going to show you how to find it on your calculator. So if you want to turn your brain off for a few minutes, that's okay. But if you want to watch this, good. I'm going to make a list of numbers up here. Okay? This is something called Pascal's triangle. And some of you might have seen it before, but it is the mathematical way we can count how many possible options we have for this situation. Okay? So if we ask the question, I'm looking at students that are on a sports team. How many different ways can I have all the students be on the sports team? There's only one way. They're all on it. So this would be, well, we'll do it from here. This would be 6 students. There's only one way to have 6 students on the sports team because they're all on it. Okay? What if we had 5 students on the sports team? Well, then that means one of them is not. But it could be any one of the 6. So this is the number of ways we can have 5 students on the sports team. This is the number for 4 students. This would be for 3, for 2, for 1, and then this one is for none. How many ways can we have nobody on the sports team? Where there's only one way, nobody. That means there's just no way. Okay? So I've shown you where these numbers come from. But now you can come back in, turn back on if you want to. Okay. So what we're going to do is we're going to use a formula that picks out the correct number of options. And this thing is, I'm going to write down the formula for you here, knowing that you've written this down already, okay? And the way this is written is NCX. Okay, letter N, small, in the bottom, then the capital letter C, and then the letter X. Okay, what does this refer to? This is the number of combinations, or how many ways we can make something happen. So I'm going to ask a question. What is 6C4? 6C4 would mean that we have 6 students and we have 4 that are on sports teams. So what I want you to do on your calculator is to find this thing. And it could be called NCR on your calculator, not NCX. Same idea. It might be in your probability menu. You have a little thing that says probability, then that's what you need. But we're going to look for 6C4, and we want to know what that is.
So if I have an NCR of my number 5.
So then you're going to hit 6, second 5, 4.
I don't see it at all.
So hit 6, my second function 5, and then 4.
Yes.
I have it under my probability.
Okay, so you hit 6, then you hit your probability menu, get your NCR, and then 4.
Okay, because there's an NPR as well.
Or, yeah, but you don't want NPR, you want
So
NC.
over, okay.
Where's that yours? Because you have a Texas and so does he.
Probability. So you have to do the function. Oh. You have to use the, oh, I see. Okay. And then you have to do over the NCR. I see. I did it. 6. Yeah.
Oh my God, I might find it.
Be a 15? Yeah.
You got 50.
What is this?
15. I got
What is this?
15.
Oh,
Thank you.
We think we're right.
See,
That
you
broke
got
me.
zero.
I'm like, what are these numbers mean? But I made it work.
Yeah, you know, you should have your own calculator.
I know you said I love it. I was like, you got way too excited about that. This is why I bring.
So my,
Yeah.
So.
Nothing wrong with it. Leftovers on there, they come home and they're gone.
Yes.
That's why I live alone.
Then that doesn't happen.
So you hit 6, ERB, and you were there. Yep. Okay. Number 6. 6,
Because like, it was like.
BRB, move over 1, 0, enter, 4, Not yet, I'm helping her.
To yourself.
Yeah. Okay. 36X. Solar.
That's the only baseball.
Oh, ho, 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 ho. Ah, you're kidding me. With A and B. No? Mm-hmm. Solar. Find. All right. Yeah, there it is.
Maybe you can want
Allie, what's you there?
This will not help you at all. This kind of
No, I know. Oh, wait.
Yeah.
One time it's
All right. Anybody still have trouble?
Did you get it? Yeah. I was really scared. You know how we can program that NCR to have, so we just have to.
Oh, yeah.
No, he didn't. I thought you were saying we, and I was like, okay, sorry, different page. I'm back. We don't. We did. Okay, I want to go home.
Yeah, you do. I can tell you know.
I'm just financial. It's not going in my purse, because it won't fit. I have videos.
Why not? Stop. I was like, we're cut off.
She had like a mile.
Somebody like, really?
She said yes, and he's like,
Oh, yeah.
Like, it was.
I did.
Yeah. I was
And then I was like.
Okay, this is 15. Now, in your textbook, they give you a different kind of a formula to find this number. And it has to do with something called factorial notation. But you don't have to know it, right? All I'm going to have you do is this right here, right? So I want to make it easier for you. That's why I'm showing you how to get on the calculator so you don't have to know the formula. The formula looks like this. MCX is equal to n factorial divided by x factorial times minus x. Okay, we're not going to use that. We're just going to use the buttons on your calculator. If you don't have those buttons on your calculator, well, you got to know this formula. But the fact is, I don't want you to do that. I want you to have buttons on your calculator. Question now.
Is the 4 given information, or is that
Yes.
like something that you found?
No.
Okay, 4 was given.
Yes. Okay. So, how does this help us? Well, it helps us because it tells us how many different ways something can happen. And so then, once we know how many ways it can happen, we still have to think about the probability of the thing happening. So then what we end up with is what's called binomial probability. So this is what binomial probability is going to look like. I want to explain the symbols, and then I'm going to give you the formula. Okay? So the small letter P is the general probability. You have to be given a general probability before you can do this problem. You have to know that 40% of the students are in sports. You can't do the problem otherwise, right? So we have the general probability given to us. We also have n. N is the number of observations. But there's something I forgot. I'm sorry. I'm going to write it up here in just a minute. N is the number of observations, the number of people that you're looking at. But when we say general probability, we have to be a little bit more specific. It's the general probability of, quote, success, unquote. We have to define a category called success. In this case, what we're talking about is being on a sports team. And we're going to be asking a yes or no question. And if they say yes, then we say, that's what I was looking for. I'm looking for people on sports teams. So I have to have something that I'm looking for among this group of people. I'm asking them all a question. It has a yes or no answer. That's why it's called binomial, by the way, because it has yes or no. So I am looking at a group, and I have to have a general, before I walk in, a probability that they will be in a category, a success. Now, why put quotation marks around it? Because it could be something like, you have cancer, or you had an accident, or you died, okay? So yeah, success is not necessarily success, but it's the thing that we're looking for. So we're saying, how many people have gunshot wounds? And we're asking a bunch of people, have you ever had a gunshot wound? And they say, yes, okay, that's what I was looking for. That's a success. Not really, but yes, it is. That's what I'm looking for, right? So I have the general idea of what are the chances. I walk into a room and I have a certain number of people that I'm asking this question. And then X is the number of successes. out of n.
So when you say out of n, does that mean like a number over
No,
whatever n is?
no, absolutely not.
Out of n.
What I'm saying is, I'm asking these 6 people, how many of the 6 people
Okay.
are going to say yes? Okay?
Sorry.
No, that's a reasonable question.
Okay.
All right? Yeah, it's a great question, but the answer is no. All right, so then when we're looking at this, we think about how many people are on the sports team. I have 6 in front of me, right? So in this situation, I'm given little p, small p is 0.40, n is equal to 6. How many could be on a sports team? I can have any number from 0 up to 6. So x has these possible values. I'm going to ask you this on the test. I'm going to set up a situation and I'm going to say, what is the general probability? What is n? What is x in this situation? What is the letter p? What is the letter n? What is the number x? And you're going to say, p is the general probability that we're given beforehand. N is the number of people that we're asking the question. And x is the number of successes that we have from those number of people. I'm going to ask you that question on the test. If you know that answer, you'll get those answers right. Okay? Now, it seems like last time we had a test, some people didn't believe me when I said things like that. I hope you believe me now. When I say it's going to be on the test, it's going to be on the test. And if you write down the things that I said and you write them on the test, then you'll get those answers right. This is going to be on the test. All right. So now we're looking at this right here. And what we have already done is figured out the probability that all of them are on a sports team. So this would be the probability of 6. This would be the probability that all 6 of them are on a sports team. We also figured the probability that none of them are on a sports team. That would be the probability of 0. Okay, we already did those 2. But now we need the formula for how we could do any. Not just 0, not just 6, but all those things in between. And then in order to make this happen, we're going to put just one more thing onto our list of things, and that is Q is equal to 1 minus P. Q is equal to 1 minus P. We already did this. If 40% are on a sports team, 60% are not. We already did that. But now we have a symbol for it. Okay? So now we're going to do the formula for the binomial probability. Looks like this.
What's that called?
This is the formula for binomial probability.
then it's the second P, like the PX, that's a little p, right?
Yes,
That's the C before the X.
it is.
Literally.
Okay.
X above the D.
It is.
Just clarify.
All
It's a
right.
whole new alphabet.
That's the formula for the binomial.
This is the formula for binomial probability. Yes, it certainly is. Okay, we're going to go through it in great detail in about 10 seconds. All right. Okay. Any other questions about the formula before we actually use it? Right? So, what we're going to do right now, we're going to use an example, and we're going to say, example, what is the probability of having 4 sports students in the art class?
Did we ever even answer the first question?
This is the only question we're going to deal with. That question that I had down there is a general question. This is a specific question we're going to answer.
So which one are we gonna be doing on homework and tests? General.
Okay, you don't need to ask that question right now.
So we don't need to know anything about general.
No. I'm not going to answer your question because I'm going to be talking for another 30 minutes. And hopefully by the end of that time, you'll understand the answer. But I'm not going to answer your question right now. Okay? I want to answer this question here. What is the probability of having 4 sports students in art class? That's the one I'm going to do right now. I'm ignoring that one that I asked earlier. That's a general question which I will answer in the future. Right now, we're going to answer this one. Okay? What is the probability of having 4 sports students in the art class? I'm going to use this formula to answer that question. I'm going to find out the probability of having 4 sports students in the art class. This is going to be 6C4 times 0.4 to the 4th and 0.6 to the 2nd.
Is it 0.4 to the 4?
It is 0.4 to the 4th. Yes, it is.
Can you explain
Sure. When I say, sorry, go ahead. Explain what.
why they're, 0.6 is squared?
This is Q, which is 0.6.
Okay.
N is 6. X is 4. 6 minus 4 is
Okay.
2.
Okay.
So that's why.
I tried making it in my head, but I was.
Okay.
The 0.4, so this is like 40%. That's just the hot, like, so that's.
Okay, I would prefer that you not actually find out what this number is until you know where these numbers came from. Okay? Why did I say P and have parentheses and 4? Because that's how many successes I'm looking for. I'm looking for 4 sports students out of my 6. That's why this is a 4, because X is the number of successes, the number of people in a category out of the group that I'm looking at. So this is the probability of having 4 sports students. That's why this is a number 4. What is this representing? This is representing, I'm looking at 6 students. I want 4 of them to be sports students. So that's why this is a 6 and this is a 4. This is 0.4. That's the general probability. I said that was the probability of having a student in sports. That's the general probability has to be given to me. I'm taking 0.4 to the 4th power because that's the number of successes. Probability of success to the power of the number of successes. What is this then? 0.6. It's Q, which is 1 minus 0.4. So it's the probability that they're not in sports. That's 0.6. And so then if I had 4 students that were in sports out of the 6, I have 2 that are not in sports. So that's why this is the number 2. So this is the probability that they are not in sports, and this is the number of students that I would say are not in sports. Okay, so that's that. Now let's find out what this number actually is. So we're going to put this into our calculator. We already found that 6C4 was 15. So we're going to take 15 multiplied by 0.4 to the 4th, multiplied by 0.6 to the 2nd.
What did you get for 0.4 to the 4th to make sure I'm doing it right?
Well, specifically, I don't do it step by step like this. I put it all into the calculator at once. I just write this in my calculator. I do 15 times this to the 4th times this to the 2nd equals. I do not go step by step with it. Your calculator understands the order of operations, and it can do all those things together. If you write down your steps,
I don't put in parentheses, I hit times, so then put them all together in my calculator.
that's correct. You don't need parentheses. You just use the multiplication button, and you just make it happen, and it gives you an answer. If you write down the steps, you'll probably get it wrong. Usually what happens when people write down all the steps in the problem like this, they round off somewhere, or they fail to write down a digit. It's much better for you to just put it into your calculator and get the answer. Kelly, question?
So the C, the 6 and the 4, the 6 came from, how many of the 6 do I expect?
There are 6 students, yeah, total.
And then you just broke it down more on that question, right?
Okay, this is my formula up there.
Yep.
I put in the numbers for the formula. I know what this is already because I did
Okay,
that thing.
okay, so you got it from that one.
Yeah.
All right.
Okay. Eric?
Oh, that squared, 0.0 or 0.6 squared, what does that 2 stand for? Where did you get?
The 2 is the number of students who are not in sports. If I have 4 that are in sports, 2 of them are not. 6 minus 4. Okay? 0.138 should be your answer. More or less? Okay? You get 0.138, then you're on the right track. All right? Let's do it for 5.
So in the first part of, the NCR or whatever, would that change?
It would become
65.
65. Yes, it would. You can probably borrow Phyllis's calculator when she's done.
This is a stupid question, but is the number of successes still 4?
No,
It'd be 5 then, right?
it's 5 now. Number of successes is now 5.
But it'd still be
But the
24
observations
to
are
the
still.
The observations are still 6. General probability is still 40%.
This hurts my head.
It does mine too.
Shake my head, as they say.
Yeah.
All right, so this should be 0.37.
0.037.
0.037. 0.037.
Another question about tests that you might not want to answer.
Okay.
If we have this question on the test, not this one in general, but something similar,
Right.
is that formula gonna be something that's given or we
Yes.
have? Okay.
Formulas are always good, almost. Okay.
Was the 0.6 gonna be to the first power then, and then not gonna be back?
You are correct. 0.6 would be the first.
So that's nothing, right?
No, it's the same thing. It's 0.6. It's not nothing. It's 0.6.
No, I don't.
Today we're taking a break.
You write that out.
Sure.
I will be back to you in the morning.
Yeah. That's where I was, and so that's just 4 out of the 6. And then the 0.4 is like the 40% into a decimal.
I actually am.
Is it?
And then 0.6 is one.
Yeah. Okay, now I want to really put my foot down here. There are no stupid questions. There are simple questions. I like simple questions. Simple questions are good. I answer them. They're simple. Okay? All right, go ahead. It is. Yeah, that's simple. It's not stupid. Stupid people would say, hey, is 0.6 to the first a unicorn? And I would say, no, it's not a unicorn. That would be a stupid question. But you're not going to ask that question. All right, okay.
My brain is
All right.
wrong.
So now we're on our way to answering the entire general question, but we're not there yet. Right. So right now, if I look at these probabilities, I've now made a little bit of a chart of these probabilities. Would I be surprised to have all 6 people on the sports team? Yes, I would be. Would I surprised to have 5 of them on the sports team? Yes, I would, because it's less than 5%. Would I be surprised to have 4 of them?
Yes.
No, I would not, because this is not less than 5%. Okay? I would be, shall we say, yeah, exactly. Because I would look at it and I would say it's a low probability, but it's not less than 5%. It could happen, but I am not surprised if it does. Okay? Now, I want to show you something which will make your life easier. I know you're happy to do so. Okay? In your textbook, in the appendix, there is a table that lists the probabilities for specific situations. And I'm going to put that up here on the screen so that you can see it. All right? Okay. This is that table. It is in the appendix of your textbook. Since you have electronic versions of the textbook, this is what's called, I'll type this up here. what you'll be looking for is end matter. Okay, it's in the table of contents. It's called end matter. If I go to book contents, end matter. And when I see end matter, it's in the appendix, the binomial distribution. What I want, that's this right here. Okay? Now, oops, sorry, one click too far. What we have here in the first column is n, the number of observations. In our situation, that would be 6. In the second column, we have x. X goes from 0 to 6, which we already know. These other columns then have general probability. They have all kinds of different options. What was our general probability? 0.4. So that's this column right here. What do we have? A list of all of our probabilities.
You're gonna attach that to the test, right?
I am.
Oh,
But you know what? I'm going to give you problems that are not on the chart.
why would you want that?
Yes, that's how it works.
I don't want the chart.
Yeah, well, you have the chart for some problems, and you don't have the chart for some of the other problems. Okay?
I definitely didn't. But yes, I-
So this is 0.187, 311, 276. Okay. So I am going to ask you questions on the test where I will give you this chart. But then I will ask you another question. And I will say, what are the unusual values of x according to the chart? So if I look at this and I say, well, 0, that would be a surprise. 5 and 6 would also be a surprise. So if I were to ask the question, what are the unusual values here? I would say x equals 0 or 5 or 6. So what are my unusual values? X equals 0, 5.
How do you know that?
How do I know that? By looking at the chart, Kelly. How do I know that? The probabilities are less than 5%, Natasha. The probabilities are less than 5% of a thing happening. That makes it unusual.
Is it,
5% would be 0.05. This is 47. This is like 19%. So no, they're not all under 5%.
My brain is fried.
Okay, we all join the club. There's a lot of other people around you that are equally fried. All right, so I'm answering the question. How many of the 6 do I expect to be on a sports team just by chance? Yes, we are. So the answer would be somewhere between 1 and 4.
So the probability is 1 to 4.
No, not the probability, the how many of the 6, how many of the people between 1 and 4 people is what I would expect to be on the sports team. Okay?
Okay. Okay, that makes sense.
Now, think about what happens here. You've got 50,000 people in lacrosse. You have a certain number of them that are infected with the flu or something. And then you say, or they've got some other kind of virus. Or it's, what is it, Sporidium or something. Anyway, they've got something, right? And a certain percentage of the people out there have a certain illness. Well then, if you've got 500 people in the hospital, how many do you expect to have those various kinds of illness? This will tell you how many people, just by chance, you would expect to have in a certain situation. If you know the general probability, you would say, by chance, I would expect this number of people, whether it's in the doctor's office or on a sports team, however many are going to be sick with a certain illness or have a certain genetic marker or whatever it is you want to figure out about. This is going to tell you, if you're just doing it by chance, what are the chances of these things happening? Now, the fact of the matter is, things don't always happen by chance. Sometimes surprising things can happen. You walk into the art class and you find out they're all on a sports team. You say, oh, that's different. I wasn't expecting that. And so then you might say, hey, is there something about this particular art class or something about these students that is causing them to take art when I did not expect this many to take art? So then you start trying to figure out what's making things happen here that are not just happening by chance. But in order to do that, you have to know what is the possibility of happening by chance. And then you find out what's not happening by chance. This is how we decide whether something works, like a medicine or a particular social program. And people who go to after-school programs have a lower discipline problem than they would be just by chance. This is how we would know. This is how we would figure it out, and this is how we would know what different factors are going to cause certain things to happen. So this is the mathematics of the chance thing, which tells us what to expect. And then if it doesn't happen that way, something's going on. However, if I walk into the art class and I say, hey, are you guys on sports teams? And they say, no, none of us are. It could just be a random thing. It just happens 5% of the time. Maybe there's nothing going on here. It's not what I expected to happen, but it still could happen. All right, now we turn it up to 11, as they say in the music world.
We're gonna turn up 10 down.
So now I'm going to have 100 students. Well, no, 150. Now, if I was going to try to make this happen by doing each one of these by hand, it wouldn't work, right? I'd have to do this same calculation 150 times, figure out all the different probabilities. Nah, we don't have to do that. It's not in this situation, okay? What we're going to find, if we say, how many do I expect to be sports? I'm asking the same question, but now my group is a lot larger. It's 150.
With all of the same information, just 150.
So we're going to say that the general probability of being in sports is 40%. Okay. Keep that same thing going. But now we're going to have the easiest equation you've ever seen. Okay.
You've ever seen?
You've ever seen.
Oh my.
What's the mean? Mu. The mean, which is mu, is just n times p.
The number of students times that probability.
Yep. 150 times 0.4. What's that?
Look at you.
But that's not good enough for us because we want to know how many to expect. And we know that the mean does not just give us how much to expect. As it turns out, we're going to use the empirical rule. So we also need the standard deviation. Okay, question.
So is the mean like the n times p?
That's just for the binomial probability.
That is just for binomial probability. Okay.
Does the mean, like, in different situations, have different formulas?
Yes.
Yes, sir.
Can they just mean something different?
Right?
Yeah, well,
Like, that's actually.
okay, that's asking too much. Certainly is asking too much. Yep. Yep. Yeah, why don't the Germans speak English? That's a great question. No, they don't. Okay, so then when we're looking at this and we say, okay, now how am I going to find the standard deviation? It's not very hard. Standard deviation. Sigma, little sigma, is the square root of n times p times q.
So why didn't we just switch and use mean and standard deviation as opposed to that one? That's why I.
Okay, it's probably not a good idea to ask why right now, okay?
We're doing that formula now, we're doing 3 different formulas.
You are correct. We're changing, aren't we? We can't use this for all 150 students. That would take us forever to figure out exactly what all the probabilities of all 150 are. So we're not going to do that. We're going to do this. It's going to be easier than doing this 150 times. How about that? Is that a good answer? Okay. What's the standard deviation? Square root of NPQ. What's NPQ? This comes out to be 6. Square root of 36.
What's Q? I'm
Q is 1 minus P.
Which is, P is what?
P is 0.4. 1 minus P is 0.6. Okay, Natasha, you believe that? Oh, yeah, there you go. All right. Now I'm going to do the empirical rule. How do I do the empirical rule?
Chart.
Do we have to make a data chart?
Nope.
Like something minus 2, something plus 2.
That's right.
You are so much.
Isn't it anything over 95%?
No.
or anything under- Oh, no.
It's the mean.
So mean plus 2 standard deviation, mean minus 2.
Yes.
Yep, I need that to be here.
Okay, so I got the mean plus 2 standard deviation.
I know empirical rule, but you're gonna change it, it's gonna be a whole different rule.
I will, yeah.
Oh,
my God.
That's it.
I can't do it.
All right.
Mr.
How do I ever? Mean plus 2 standard deviations. All right.
It's so frustrating.
What's the mean plus 2 standard deviations?
Doesn't matter right now. That's what I understand.
Frustration is kicked in at an all-time high.
Yeah. That's what happens.
Turn into give up.
66 or 54.
No. What's 2 standard deviations?
Oh, sorry, that's.
The standard deviation.
What's the mean?
That's right. Standard deviation times 2. Yeah. 2 standard deviations would be the standard deviation times 2. Right? Yeah.
Wait, the mean was the mean is 60.
The mean is 60. What's the standard deviation?
6.
6. What's the mean plus 2 standard deviations? Which is
72.
72. That's right. Okay.
So what did we say was standard D, was the 6?
Standard deviation was the 6.
Yeah.
And here where I have standard deviation. I
Can you
wrote
go back like 4 steps and tell me how you got that, because I'm not there now.
Okay, n is 150.
Yep.
P is 0.4.
Yep.
Q is 0.6.
Oh.
That equals 6?
Oh, okay, so I was,
Take 150 times 0.4 times 0.6, and then take the square root of that.
okay, so I was used to run the version 2.
Yep. And I'm happy to go back. I'm always happy to go back. If there's something you don't get and we missed it and you say, we need to go back, I want to go back. Okay, let me try to emphasize this a lot. If there's anything up here that doesn't make sense to you, and I'm not saying you're comfortable with it, but if you don't understand how to put it into the formula, then I want to fix that. If there's something where you say, I don't know why we're doing this, that's absolutely right, you don't. And you're not gonna for another 4 weeks. But if you say, I don't know how to get this number, I want to fix that right now. So if there's anything you're looking up here and you say, I don't know where that number came from or how to get it, I want to fix that. If you're like, I'm just uncomfortable with these numbers, sorry. But if you don't know how to get the number, we fix that now. We go back, doesn't matter.
So right now we're finding the boundaries.
We're now finding the boundaries using the empirical rule, yes. The top one is 72. What's the bottom one?
48.
48. So we have from 48 to 72. Eric, how much data is in between those two numbers? In the empirical rule, no. In the empirical rule, how much of the data is?
Oh, 95%.
95%, okay? So this would be where we would expect to happen 95% of the time. We would have between 48 and 72 students in sports out of the 150.
And so then, like, for example, 47 would be.
That's correct. So if I have 150 students in my assembly, and I say, okay, well, let's celebrate all the sports-minded students. Everybody that's in sports, stand up. And I had 10 people stand up. I'd say, wait a minute, this is not right. This is not how it's supposed to be. But if I had 90 of them stand up, I would say, there's something going on here because there's only supposed to be between 48 and 72. So I would know what to expect if these students are just randomly showing up to this assembly. However, if there's some schedule conflict and none of the sports students can show up, well, then it's not going to work now, is it? So this is how I know if I have a large N, okay, a large N, then I'm not going to find each one of these probabilities separately. I'm going to be using the empirical. Okay, so this right here, this stuff right here works because I have a large N value. I have a lot of people, and I'm not going to do all of them separately.
So once you hit like 10, you flip over to that.
Okay, we'll talk about that later. Okay,
For the
right
it's small
now,
numbers,
right now, okay. Okay. What's going to happen on the homework? You're going to have situations like this, where you're going to be asked to find specific numbers of people out of a group of people. And you're going to have a formula. You'll also have questions that use the table. And you'll just look up the table and write down the number. It won't be too hard, right? There'll also be situations where it will say something like this. At least 4.
You just assume 4 then.
If it says at least 4, how many people is that if it's at least 4? 4, 5,
6, 7, 8, 9.
6. We only have 6.
Okay,
Okay, yeah, but whatever, right?
Okay.
If it says at least 4, then 4 is included, and then you also have to include this one. And you also have to include this one. So then you would have to add these probabilities together. When it says at least 4, then that means you add together the probabilities for all the different things that could happen. Okay, so that's going to be a type of problem you're going to have on the homework. You'll also have problems where you'll have a relatively large N value, and it will ask you for the mean and the standard deviation. This is what you'll do for that. Now, of course, if they ask you for the variance, you just square the standard deviation that gives you the variance. All right, so I think, yeah, that's enough for today. And have a great weekend then, and I'll see you on Monday for another turn of the
I
crank.
think we should just stop.
Oh, wow, that would be great.
All of our exes. Statistics. Really glad that you heard that. Avery. I know. I'll have to talk about that.
Hey.
I went to open, home ec number 6 for me.
Oh,
I'm so good at that, yeah, jokes.
Because I was doing home ec number 5.
oh, okay, sure, yeah, I can change that. I'll do that. I will do homework number 6. Sure.
I saw this really funny thing, like,
No, I mean. Guys are ready to celebrate all of our success. You mean celebrate all of our exes. Yeah, Amber was the only one that heard it. She laughed.
You're gonna be, in tomorrow?
Yep, 10 o'clock, hopefully.
I don't know, I'll need you for anything.
Sure, yeah, just in case. Yeah.
We can throw out and just stop by.
Yep. Well, actually, I do have a few people that are gonna come in. Let me just take a look here. I got that on Outlook. Tomorrow, the 7th. Yeah, I've got somebody from 10 to 11, and I got another person at noon. But other than that,
Oh, I can't. It can be usually.
I stay till 3, so.
Are we gonna need to know any more about that Pascal?
No.
Something.
No, that's just how we got this number.
dude, that last time.
You want us to know
Mickey's class
the
is called-
equation.
All you have to do is put this in your calculator and get this number. That's it.
Okay. Thank you.
Sure.
I forgot Wilson. Oh, Nikki.
All right.
You happy to see you or something?
No, I don't know. I was just talking about you when you walked in.
Uh-oh.